The commutative and associative laws are four axioms of the real number system. Remember that the real number system is the collection of all real numbers, the addition operation, the multiplication operation, and a binary relation less than or equal to. The binary operation addition combines two real numbers a and b to produce the real number a plus b. Now, we have certainly learned that 7 plus 3 will give me the same result as 3 plus 7. This is so obvious that you have probably not spent time thinking about why this is true. For the purpose of rigor, this is introduced as one of the axioms of the real number system, and we say that addition is commutative. A plus b is equal to b plus a for all real numbers a and b. The word commutative is derived from the word commute, which means interchange two things. And that is precisely what is happening here. I can interchange the two real numbers a and b, and the result will remain the same. So we do not ask why 3 plus 7 is the same as 7 plus 3. It is simply a rule of the game. The commutative law is one of the rules for manipulating meaningless symbols, and is one of the fundamental ones, one that cannot be derived from other axioms. In this lecture, addition operates only on real numbers. As we dig deeper into mathematics, we will consider objects which are not real numbers, such as functions and matrices, and we will allow addition to operate on some of these objects as well. In such a case, addition may or may not be commutative. It all depends on how we define addition for these new objects. One thing that will never change is that addition will always be a binary operation. It will always operate on two objects and return one object. Next axiom, multiplication is commutative as well, a fundamental property of the real numbers that we never attempt to prove. If you encounter an expression such as 4 plus 3 plus 2, it will cause you no confusion. The result is 9. However, from a strict point of view, addition is a binary operation. It needs two arguments, and this expression is strictly speaking invalid. If we look at 3, is 3 the second argument of the first addition, or is 3 the first argument of the second addition, or is it both? That's not clear. We can easily fix this by introducing a parenthesis. If I instead write 4 plus 3 plus 2, this is in all respects a valid expression. 4 plus 3 should be calculated first, and it is the real number 7. In the second step, we calculate 7 plus 2, which is 9. However, we can also fix this by introducing a different parenthesis. I could also write 4 plus 3 plus 2, with a parenthesis around 3 and 2. Which is also a strictly valid expression. That leaves the question, what exactly do we mean by 4 plus 3 plus 2 if I have no parentheses? Do we mean the first case where 3 goes with 4, or do we mean the second case where 3 goes with 2? Fortunately, we are well aware that the answer is, it doesn't matter. The result is the same. However, this is not something that can be proven from the other axioms, so we need to take this as yet another axiom. And this axiom is called the associative property of addition. Associative means to join or connect together, and we see two different ways of associating the numbers a, b, and c. On the left-hand side, b is associated with a, while it is associated with c on the right-hand side. According to the associate law, you can associate B with whomever you like. Because of the associative property, we can write A plus B plus C with no parentheses. The final axiom in this lecture: multiplication is associative as well.